In this video, I'm going to talk about tangent to a curve. Now, I talked about secant lines a while back. Here's your curve, and it doesn't really matter whether it's a hyperbola or parabola or an even ellipse, which is something we will talk about in future videos. All that's important is this line right here. This line right here, as you see, meets that curve at one point. That's called the tangent to the curve. Now, if it met it at 2 points, it'd be the secant line. But because it only meets it at 1 point, it's called the tangent to the curve. Now, in a little bit, you're going to see how hard it is to find the slope of the tangent to the curve. Now, what do we mean by slope? Well, that means the direction the line is actually going. Is this line going this way, or, well, it could go lop-de-doodle anyway. Okay? Now, we're going to talk about the Cartesian coordinate system. And if you don't know what I'm talking about, you need to go back a few videos to check out the Cartesian coordinate system. Check out slope, check out y-intercept, whole 9 yards, because I talked about all this in previous videos. You should have been watching this, and if you weren't, well, you missed a lot. Okay? Anyway, to find a coordinate on a curve or a line or both, you would go a certain number of steps horizontally and then a certain number of steps vertically. And those are your coordinate points. And I talked about abscissa and ordinate. And if you don't know what I'm talking about, you need to go back a few videos and look up abscissa and ordinate, because I talked about both. All right. Now, let me show you the difference between trying to find a secant line, which is real easy to do, and finding a tangent to a curve, which is a bear to do. All right. Do you remember our friend Mr. Slope? Here are your vertical coordinates. You have one vertical coordinate, you're going to subtract the second one, and then you're going to divide that by the total of one horizontal coordinate minus the other horizontal coordinate. So these are two vertical coordinates, these are two horizontal coordinates. Okay? And whatever you get from here and from here, you divide this by this, and you get the slope of the line. Alright, now if you'll recall correctly, I talked about this little symbol called delta. This is the change between where a point is on a number line and where the next point is. Okay? So you have the change of y minus y and the change of x minus x. And this is represented here. Okay? So here again are your vertical coordinates. These are functions. Anytime you see that f there, that's a function. And I talked about that in previous videos. And I will talk about that again in some more videos. So if you think this function thing's over with, forget it. You're going to have a lot more discussion about functions in the not-so-distant future. So get used to it. Alright. You have one vertical coordinate. You're going to subtract another vertical coordinate from that. You have one horizontal coordinate. This is a horizontal coordinate right here. And then you have another horizontal coordinate. And when you get done with that equation, of course you see f of x plus h minus f of x divided by h. Now how do we get that h? Well, x minus x is 0. So all that's left is h. Now let's take a look at an equation. Okay, this is a linear equation. This is a line equation. Alright, now let's go on here. We have an equation here. This is a number line equation. It's 2x squared minus 3x plus 1. Okay, so what we're going to do is we're going to replace that y here with f of x. Okay, alright, or actually f of x plus h. Alright. So, the actual abscissa and ordinate here is x plus h, okay, and the f of x plus h. So, x plus h is the x-coordinate, and f of x plus h is the y-coordinate. So, we're going to substitute this here, this x plus h, to here, and to here. So now we have 2x plus h squared minus 3x plus h plus 1. If we expand this out using the FOIL method, which is something I talked about in a previous video, I know you're getting sick of hearing this, but I talked about it in a previous video. Well, then you get 2 times x squared plus 2x plus h squared minus 3 times x plus h plus 1. And then we go down here and we have 2x squared minus 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. And that's everything expanded. Now, if you'll remember from our little division right up here, f of x plus h minus f of x divided by h, which is right over here, f of x plus h minus f of x over h. Well, we have to subtract this here from this. And how do we do this? Well, we set up a little, not necessarily synthetic division, but this is, well, basically a subtraction problem here. Alright, what is the f of x plus h? It's this equation right here. We just went over this. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. What is the original equation? Well, that was 2x squared minus 3x plus 1. We've got it listed right here. When we subtract this from this, we get 4xh plus 2h squared minus 3h. But we're not done here. Okay? Now, we have f of x plus h minus f of x over h. The result of this is right here. This here is the result of this. So now we have 4xh plus 2h squared minus 3h divided by h. We're going to factor an h out of this. So now we have h times 4x plus 2h squared. Plus 2h, sorry. H times 4x plus 2h minus 3 divided by h. Well, we cancel the 2 h's out, just like that. And now, this equation right here is this right here. And that's the equation for our secant line. Okay? But we haven't even talked about tangent to a curve, which we're going to talk about in the next video. So stay tuned.